Thank you, everybody. I appreciate you having me here, and I appreciate you all driving here. When I landed at the airport, I got a rideshare to my motel. It was really dark. I arrived really late last night, and I am so thankful that somebody in the city knows how to drive here. We weaved in and out of all that construction and everything, and I was completely lost. So apparently it's not easy in the rain here either, so I do appreciate you all coming out to see me. All right, well, Ari already did a fantastic intro of me. I feel very, very embarrassed now, but the one thing I just wanted to point out here, I am a member of the CDF. I'm a TOC member, but also a co-chair of the Interoperability Special Interest Group. And that group is really special to me because I really feel that with everything happening right now and with all of the components and everything that we put together with all of our applications, we really need some standardization, a singular language that we all speak, rather than all of these tight integrations between every single product that we bring in to our environments. So just a simple advertisement for that. This is my contact information. I killed Larry on this slide. It made me very sad. So I still do have a X handle. And here's my LinkedIn as well, where you can reach me. And I'll show my contact information again at the end. All right, this session is about the intersection between security and the real life of a developer. And this is pretty light-hearted. It is meant to inspire you to start these discussions if you haven't already. I assume you have. But to have deeper discussions within your team about the tools you're using, about the culture that you have right now, about the different teams within your organization that you're working with together to solve these big issues that we have. Sometimes the quality of life for a developer can be pretty bad in some scenarios. And how many times, maybe even not as a developer, but in any employment opportunity that you've had, how many times you've been in a situation where you're kind of unclear about your job responsibilities? Yeah, a few. So I've been in that situation as well, and there's a number of problems that happen there, but I will say that it is one of the most frustrating and dissatisfying things to not know if you're doing the right thing or if you're stepping on someone else's toes, or if you're doing it well. So this isn't meant to be a talk about job satisfaction, but when it comes to security and developers, this is what comes to mind to me. We're asked to do a lot already as developers. We work on honing our development skills. When methodologies like Agile came into play, we needed to adjust and adapt our approaches to project management and planning. How many of you have worked in an Agile environment? Yeah. Back when I asked this question years and years and years ago, the hands were a lot lower. So I think most of us have had experience in that world, especially switching from one to another. When DevOps came about, the next buzzword that came about, now all of a sudden we needed to add a bunch more stuff into our toolbox. My introduction to DevOps was pretty abrupt. I didn't really have the background or the training. I was a developer. I coded in Java. This is what I knew. I was planted on a team to help start from scratch, and the first responsibility was to set up a build server. We looked around our organization to see if there was something already in place that we could use. There wasn't, at least not one that we could easily find. This was a huge organization. I won't name it. But I got the responsibility of setting up a Jenkins server for the first time in my life. I did it. I was successful, things were running, things were great, but what do you think the first thing that happened to me was? It died because it ran out of memory. Just simple problems like that someone, maybe with more of an ops-specific background would know. They would have more experience with these tools. I was a seasoned developer, but certainly not in the ops area. These were tools that were already set up for me, and I usually was just given a login or access, things like that. Same for our storage, like for Artifactory. I didn't know that Artifactory was JFrog. Had no idea. It was just a URL. That is where our stuff came from. That's all I knew. and all I cared about for a long time. So now we're in this season of DevSecOps. And once again, we're having to adjust. We're having to add new tools to our toolbox. How many of you have been involved in patching a critical vulnerability? This is a Java user group. I expect most hands to go up. Yes. This is very important. Lots of consequences in not addressing security issues. Just some listed here: theft of private data, loss of money. That includes salary time, developers' time in mitigating this issue. Perhaps you might be able to stop an attack at the edge, but you may still need to fix your application. So now you might have to add another release cycle to your application, things like that. And then loss of credibility. We've all seen the news stories every time someone gets hacked. We're all made aware of it. It's getting to the point where we're a little raw. We're a little used to hearing this over and over again. And it feels hopeless sometimes because it feels like we're never going to get ahead of this game. And the sad part is we might not. We're getting better, but there's always going to be something coming down the road. So the health of your development and delivery environment is super important so that you can react fast when something does come down the pipe and something does affect your application negatively. I'm going to go through some of these famous hacks. I picked old ones. We've all heard of these before, probably. There's reasons I'm picking these ones specifically just to highlight the cost. This was the Equifax data breach. Happened quite a while ago. It went through March through July of 2017, so it's been a few years. There were $1.4 billion in cleanup costs and $1.38 billion in consumer claims. There were 143 million customers that were affected, and this was all because of the Apache Struts vulnerability. This next one, Log4Shell, we're all familiar with this one. The ability to trigger a remote code execution by providing a string in a certain format that ends up being logged. Pretty interesting vulnerability, but it turns out that it opened up that ability to initiate an LDAP lookup and fetch some compiled code and run it. And just about every Java developer out there cringed their way through fixing this vulnerability because this guy was everywhere. More recent data breaches. Last year there was a Slack data breach. There was some unauthorized access to a GitHub repo. There was a Twitter breach, pre-X breach, users of email addresses. This is a site that I found that kind of keeps you updated on the latest data breaches. Data, of course, is a huge motivator for hackers due to the value they get from distributing that data. And this quick search came up with this article. The last time I looked at this article, it was June. And there were 6 significant data breaches in that month alone. A couple interesting ones. There was a MoveIt hack that affected Zealous, British Airways, the BBC, and others. And MoveIt is a popular file transfer tool that all of these companies were using. June 19th, Reddit data breach. Hackers that claim to be from Black Cat ransomware gang. They threatened Reddit with leaking 80 gigs of confidential data that they stole from its servers. I went back to this article just recently to see if there had been any updates, and yes, there's a ton more in July. In August, it was updated today, actually. There's 3 more data breaches just in August. The most interesting ones I picked out because they're repeated. The MoveIt vulnerability attacked again on July 20th. This was called the PokerStars data breach. It was an online poker platform that suffered from this. They no longer use that application now. And then August 11th, there was the IBM MoveIt data breach where 4.1 million patients in Colorado had sensitive healthcare stolen. So I'm really curious, just, developer mindset kicks in. Why are we having these problems repeatedly? And there's several reasons for that. We'll go over a few. But what I really want to do is just find the cause and find the cure and just fix it. So I go back to something that I learned as an intern years and years and years ago. What is the problem you're trying to solve? Don't get distracted by all the extras. What is the actual problem? And I think it's a little bit bigger than just learning how to code better. We'll talk about that. This was the first thing that came down on my plate. It is a developer's responsibility to write code that is secure. All of you here are developers, meaning you write code for your job. All right. Do you all agree with this statement? Seems legit, right? Yeah.
It's sort of a half-truth.
It's a half-truth?
Yes, because if all the pieces are secure, what's between them?
That's right. That's one thing. Yes. Yep. You read my mind. We will get to it. This is a article that I found on the OWASP website. It is how to write insecure code. I really enjoy this one because all of the times that we're taught how to write secure code, sometimes we just don't really get the why behind it. And this article explains in great detail all of the things that you could possibly do to make your code less secure, how you do it, why you would do it. It's interesting. And it's funny enough that I want to go through some of the funnier points. These are just a few that I picked out. Always use default deny. Make sure that, deny that your code can never be broken. It's perfect. There are no vulnerabilities until there's a proven exploit. Deny to your customers that there was ever anything wrong, and above all, deny responsibility for flaws. Blame anyone else but your application or your code. Secure languages. I really liked this one. Pick only programming languages that are completely safe. Don't require any security knowledge or special programming to secure them. This one's an easy one to do, right? Yeah. Mix languages. How many of you work in multiple languages, not just Java? Yeah. Anyone who deals with the front end at all, you're likely using another system. I worked in the media industry for quite a while. We ended up using a lot of Python just because of existing libraries there. Interesting stuff. We're all cobbling these things together, so it makes it really easy for us to fall into some traps. Here's some more. Rely on security checks done elsewhere. This is a big one, and it follows along with whose responsibility is it to catch these things. Trust insiders. Of course, everything in your database is perfectly validated and coded and sanitized. I love this one. Code wants to be free. Drop your source code into repositories that are accessible by all within your company. This prevents having to email those hard-coded shared secrets around. All right, I'm going to show this again. When you see a QR code like that, it's just a code to the URL if you're interested in collecting this to read later. And I can share my slides too. So it's pretty clear that developers need to care. We all agree that we need to write code that is safe. So educating developers is super important. We can't just let them go out and be, free range and do whatever they want. We've got to make sure that they're doing the right thing, coding things appropriately, and they know what they're doing. I bought into this heart and soul. I was, thankfully, the company I was working for decided to give us all training in this area. There are lots of paid services that do this for developers, and in our case, we were able to choose the languages that we wanted to learn. Some of us were, maybe we were experts in Java, but we were picking up Python, or we were picking up .NET, or we were picking up, Go, or JavaScript. And so it was pretty easy if you're not familiar with how to write the code, how to avoid some of the pitfalls that you run into. So I was pretty excited. I went through the Java training. I learned all about cross-site scripting, SQL injection, LDAP injection, cross-site request forgery, insecure cryptographic storage, and I really thought I had everything under control. And it's not that I was an idiot. I've got to be, kind to my past self. It's just that fact that you don't know what you don't know, and that's the whole point of this session. A lot of developers weren't given this education to begin with. We were more focusing in school in the beginning, just focusing on getting something to work. So I had my bachelor's degree in computer science. How many of you have a computer science degree or you've been through a boot camp of some kind? Okay. How many of you took a class in security during that period of time? I had more questions, but I only have one hand left. Was it a required core class or was it an elective? It was both. So a required elective. You had to choose in a... Required and elective. Oh, okay. Okay. So this is comforting to me. I was worried I was going to be the only one that did not have an official security class in school. Of course, you can go on for further education, get a master's in security, something like that. Most of us don't. I mean, most of us working in the regular organizations, we aren't going to do that. So it turns out there is a lot more to be concerned with than just developers writing secure code, like the gentleman in back mentioned. There are some other aspects that we need to pay attention to. And here's the half-truth. So remember the SolarWinds hack? This added 4,000 lines of malicious code to the Orion platform DLL. This was done after compilation, after developers had done their stuff and they coded safely. What happened was by the time their application ended up on the CI system, the normal build routine, the binary was switched on that system. So somehow someone had access to their build server or their pipeline. 18,000 customers received that update that was produced with that cycle. And that update had a backdoor. So this is way more complicated than just developers writing secure code. There are more things that we need to concern ourselves with, and as developers, we need to be aware of. So I identified two categories right off the bat. Software security, we already talked about the code. The protection, preventing things by writing safe code, making sure that you're not coding in weaknesses that are well known. Managing your source control, making sure that not everyone on the planet has access to your source control, that there's always a review of what goes into your main branches, and dependencies, bringing in your dependencies into your project, making sure you know where those come from. Supply chain security. Again, your dependencies. This is huge. I can't talk about dependencies enough. The build process itself is important. Again, we want to control permissions to that process. We want to make sure we know how it's working and what components are being brought in to our environments. Referencing or transitioning all of our artifacts through that software development lifecycle, the development and the delivery pipelines. One thing I want to point out here, how many of you use Maven? Right? How many of you use Maven plugins for building Docker images, for example? Okay. Do you know under the covers what's actually happening there? Yeah. A lot of us don't. We get a tool. It works great. We don't ever investigate further down what's happening. So I'll talk about that one again in a minute. Along with those other categories, the software security, we already talked about this, all of the ways that a developer needs to pay attention to how they code their application. This URL, the OWASP.org, it's an organization that really does well teaching you about these items specifically. They have a famous, top 10 list that you can really, pay attention to. If you haven't seen this, definitely go take a look. Supply chain security, some examples of this are typo squatting, which is basically having a package, let's use NPM as an example, having a package that is named similarly to a legitimate package, but it's actually a malicious package, and maybe you can't remember exactly what it's called, but you do a little tab complete and you bring in a package you didn't intend. Dependency confusion attack, I'll give an example of that. And then, of course, unauthorized access to portions of the build process like we saw with SolarWinds. So the dependency confusion attack, I really like this one when I learned about it. Alex Bersan wrote a really good Medium article on this. It turns out most projects do have a collection of dependencies. They need to be collected during the build process. They include open source or publicly available packages as well as internal packages. These internal package names are highlighted here in this example. They note that the version requirements are just that the version is either the one specified or a greater version. So there's this great idea where you can give yourself flexibility to magically update your packages when you build. It's great. It does the work for you and brings in updates. These package names also, even though they're internal to your company perhaps, they are not secret. Once you make that request, it goes out to the public repo and searches for those package names. If you know an internal package name and you are intending to be malicious, you could go and create a publicly available package, put it out on NPM, and give it a high version. And the end result is that when you build, the priority goes to the higher version that's available publicly. So we can kind of see this happen here. And then who knows what's going to happen to your application, or at what point you're going to discover that you pulled in the wrong library. One solution for this is to get a something like Artifactory or any tool where you store all of your artifacts, and you can actually block the requests from going out publicly if something is already available internally. By default, this is not how it works, though. You have to know to do this and go in and set it up that way. So this is the QR code is to Alex Bersan's original Medium article about this. He does go in great detail about what he did to discover this vulnerability. So your chance to read that is here. But all of this resulted in some pretty large bug bounties. Lots of money involved in this business. Is your software delivery process healthy? I can easily see a developer getting duped by that dependency confusion attack if there aren't necessary restrictions that were made on the repositories that they were pulled from. The same problem exists with build servers as well. Most issues around dependencies are things that developers can and should be much aware of. So there needs to be a serious and deep look into how your code is managed from beginning to end. And what I often suggest for teams is to whiteboard everything. It should be no secret what is happening at each stage of your build, at each stage of your testing, building not only on your developer box, but building in the build environment on your build server when stuff gets checked in, and then how things are delivered. Focus on the source of your artifacts, the source of your code. For every step in your pipeline, you need to know the source of your code artifacts. This is everything that your project depends on. And if you can't answer where everything is coming from, for example, where are the images coming from, the base images coming from when you use the Maven plugin for Docker? Where are those coming from? And if you watch your development environment, when you pull those in, there's some extra images that get pulled in along with your application. So you'll end up with a few extra images in there. Those are not under your control. Those are developed somewhere else. One option for that particular problem is to find where those are coming from, pull them into your local environment, your storage area, so to speak, for your artifacts, and make sure that every developer has access to them there. That way you control when they get updated. You're not on someone else's schedule for those to get updated. And when they do need to be updated, you have control over them. Let's talk about the development process. We start with the developer, choose your language and framework. Let's just say Java, just for fun. You need a package manager. You choose Maven or Gradle. You list all of your dependencies in a POM file, and then you reach out to a global central repository. The biggest problem that we see here is transitive dependencies. You've listed everything that your project needs, but what about everything those dependencies you brought in needs? There's a whole tree of those. Run Maven tree, you can see just how complicated your project gets, and then you get into that whole situation where you want to prefer one version of a library over another because multiple dependencies have pulled them in. I think a lot of us have been in that mess in our lives. And most developers want to work smarter, not harder. So we don't like to reinvent the wheel. We're often going out and finding code that already works that we can build on top of. This saves us time, it saves us effort. If we're lucky, we find libraries and packages that are well maintained from trusted sources, and we bring these into our environments. We won't get more complicated or more advanced software without doing this. We're building on the shoulders of each other. This is a good thing to do. I certainly wouldn't advise to stop doing this. I just advise to be aware of what you're doing so that you know what to look for when problems arise. Build servers get more complicated. They're meant to be tools for automating that whole process that I just described. They do behave the same way unless they're configured differently, meaning that when your build process starts, it brings in the code, it builds the code, and it also reaches out to that public repository. One suggestion here is to cache what you need, bring those in internally. A lot of organizations are set up this way already. You may be behind firewalls where you're not allowed access to remote Maven sources, but you have a path through like Artifactory or something that has room to go out and query for those resources. Even with the protections within your organization, I have a daughter at home right now, and she is starting her CS degree. She has got security classes, by the way. I'm so jealous. I'm looking over her shoulder and asking her questions. But it's pretty good to see that that is happening now. But she gets really excited. Now, she's a very, very junior developer. She started with Python. I'll never understand that. I tried to get her started on Java, and she refused. But she did admit she just didn't want to do the same thing her mom does. So she's rebellious. But she's so excited about Python, and she's like, oh, there's a library that does this, and there's a library that does that, and she's using PyPy, and I'm just cringing because she's in my house on my network. Right now, actually, and I'm here, there's no protections. So I am concerned that we don't educate developers enough in the very beginning So I understand the excitement, I understand the passion, but we need to work on getting safety zones put around our junior developers. Anyway, so a build process here may have multiple steps. So not only do you have your regular build process for like a Java app, but now maybe you want to contain it. So now you're building a container. Now you've introduced a whole another load of dependencies that you may not be paying attention to. There's a whole base image to be concerned with. There's any changes made after that fact in the Docker file that you need to be concerned with. Maybe additional packages need to be added for your application to run and work correctly. Those need to be managed and updated. So all of that is built in, and we have these wonderful tools that we can go out, so we don't have to maintain our own build servers at all. We can have someone else do it for us. And guess what they do? They do it inside containers. And do we necessarily know what their container is made of? What it might be injecting into our stuff? I hate to be paranoid. We have a lot of trust in our industry. We all love each other. Developers are constantly helping each other out. Some of us just want others to know how much we can do, so we push so much out there for others to use, and we're very helpful people. So there is a lot of trust, but there are some that are malicious and some that we have to be careful of, and some just lack of experience and maybe are building in some weaknesses into our projects that we're not aware of. So I encourage you, go back to your teams, find out how your build actually works, like what is happening on your local development box and what is happening on the build server. I was always curious to find, sometimes it's completely different what happens on my box and what happens on the build server, just because the way that they're pulling the resources is different. So go take a look at that. All right, this is a very, very contrived Docker file. It came from a talk I did a few years ago called Docker Do and Do Nots. That was a fun talk. I only picked 10 items. There's a lot more, trust me, to be worried about. But let's just go through this little Docker file here and talk about some of the problems that we can point out immediately here. First, obviously, a name like untrusted parent image is bad. Unfortunately, it's never so obvious when we've picked something that maybe isn't the best for our project or even mistakenly named. There's no tag or SHA identifier here. That's a problem. By the way, if you are using a base image, best to use the Docker official images for that if you can. There is a whole separate team that maintains those images, makes sure that they are regularly updated and scanned for vulnerabilities, at least known ones. So they're a little more trustworthy, I would say. If you don't do that, build it yourself. Make sure to start from scratch. How many times, I don't know the last time I've seen a Docker file that actually started from scratch. It's been a while. But it's nice. Usually platform teams might do that for you, build base images for your organization to use. Really convenient if you're looking for specific versions of Java or you're looking for specific functionality. Lines 2 through 4, a little bit of a different problem, but the same, not specifying versions, not keeping up with updates. So you could have old packages in there, packages that get updated the next time this Docker file is used in a build on a fresh machine with no cache. Line 6. This is more of an efficiency and performance problem. What this is doing, I see this line a lot, especially in example code, because it's the easiest thing that works. When you're first learning something, it's nice to just get something that works without getting into too far down in the weeds. But when you do a copy like this, it's basically taking your entire working directory and getting it ready and available for the daemon to pick from to put into your image. What ends up happening, though, is think about all the things you may not want in your image. If If you have any environmental specific code or secrets, those are going in there. Your .git directory is going in there. I'd be really curious if you actually go to your Docker containers and view the layers and see exactly what's in there. You might be surprised, especially with some of the directories that end up in there that shouldn't be in there. Line 7, this is my favorite one. Again, we have a lot of trust in our industry. It's one thing if this particular location was an internally managed resource. That's one thing. But I've actually been on a project before where we relied on a vendor to provide us with a proprietary piece of code that we needed to include in our application, in our container. And there was a curl statement. Now, I'm sure somebody at the beginning actually read the script to see what it was doing, but I mean, that happened at the beginning of the project. So what you would do, or what you would want to do instead here, is take that script and move it somewhere internal where you manage the updates and you manage where the access to it. I will say that that particular project, we didn't do that until it broke because the vendor decided to change permissions on the directory. And we weren't smart enough to do it then. We did it the next time it broke when they deleted it. So yeah, save yourself that anxiety. 9, running as a root. I feel bad about harping on this one a lot because I hear it all the time. Every talk about Docker and creating containers and things like that is running as root. I feel bad until I see this statistic here. This is from a usage report that Sysdig gave out in 2022, and they analyzed a ton of containers that they were monitoring, and this many, 76%, were still running as root. It's default, so it's easy to fall into this trap or just not understand the importance or the reason why you wouldn't want to do this. And there's also a lot of containers out there that run as root for a specific purpose because they need to or they have to. I argue that, but it exists. So it's an interesting problem. Anyway, these are a few of the items just to keep in mind when you're building images. They don't have to be Docker images, any image. Use those trusted or official parent-based images. Don't use bulky parent images. When I was first learning, I thought it was the most convenient thing in the world to include Maven in my image because I was using the Docker file to actually build it too. I thought that was great. Don't do that. Use multi-stage. This was pre-multi-stage build, so I had an excuse, but still. If you choose that route, use a multi-stage builds where you can choose only the result of such an activity and move it into the final container. So it's smaller, less attack area. Specify all the versions, all of them. Use a .docker ignore file. This is the file, it's related to that copy statement I showed you before. All the things you do not want in your container, use a Docker ignore. This is also helpful, even if you specify the things that you want in your container rather than doing a global copy, it still will send everything over to the daemon and then pick the ones you chose. The Docker ignore file will eliminate that step entirely and only bring the things you specified. So it'll save time on your builds. Make all your external resources internal, and of course, don't run as root. All right, deploy process. Are you rebuilding when you release? I was on a project once and was horrified to find out that I did, I really tried to make it pure. I had the artifact. This is the artifact that went through testing. This is the artifact that was built. And then when it came time to release, it was rebuilt so that the version number would be different and then sent off to production. Don't do that. You're running some risks there. They may be small risks, if you do it, all of that internally, but I mean a bit could be flipped in your production image. You don't know what happened. You're duplicating that image. I'm going to date myself here, but ever record over and record over and record over those little cassettes? Make copies of copies? Yeah, same problem. Are your build servers protected appropriately? Just like the SolarWind attack, make sure that you're paying attention to your permissions and who has access to these machines. Last development team I was on, I think we all had access because we were all tired of one person trying to fix the build every time it broke. So we still struggle with that issue, but just consider who actually needs access and explain to your group that not having access doesn't mean you're not trusted. Usually it means so that you don't accidentally make a mistake and kill an entire pipeline or something like that. More categories now. We've got more issues. Permissions and environment security. I'm just going to leave that there. I think we all know what that's about. Anyone here work on AWS? Anyone here want to work? I'm so mean. No, it's so huge. It's so huge, and I think one of the most frustrating things for me is just dealing with IAM stuff and trying to get that right. So yeah, there's a lot of work that could be done there, I think. All right, so we have established it is not all up to developers. This is a bigger problem. It is not just the coders that are going to have to be involved in this. There's a lot more people that need to have visibility on this. What have we done? Well, now we have regulation. Now we're going to have to start, putting up with laws, and unfortunately, this is how human beings work. We have all of our freedom until somebody ruins it for all of us, and now we've got to follow the rules. So now we need SBOMs if you're going to be involved in working on software for the government. This is for the US. We got an executive order on improving this stuff. It's not just the US. The EU is now starting with legislation about this as well. Something to look into. We are really trying to deal with this problem with creating a catalog of known vulnerabilities. So we have these organizations. We've got the CVE, we have NVD, we have CNAs. CVE stands for Common Vulnerabilities and Exposures. We probably all know that by now. NVD, National Vulnerability Database. And CNA is an acronym inside of an acronym. It is CVE Numbering Authority. What those are, JFrog's actually a CNA. There are many organizations that are CNAs, and they are basically those that have committed to searching their code for zero-day vulnerabilities and creating fixes for them and assigning CVEs to them. It's a good thing to have. More and more organizations are getting involved in this. It kind of gives you a little bit of cred, but it also helps the community as well. I know JFrog focused a lot on Python packages and JavaScript packages out there that could possibly be problems for others. And we're able to find lots of CVEs. There is a lot of security-focused research that's publicly available. This is an example of an article that was written by one of our security researchers. It's a report about the most impactful vulnerabilities. What should we do? What should we continue to work on is adopt and implement security tools that make sense. We'll talk about what that means shortly. Organizations, you need to train your people. Again, developers should not be expected to be security experts. I think we have a whole generation of folks in here that did not have a security class. So we're all picking this up on the side with our full-time jobs and expected to know this. Making those processes transparent. There should be no secrets to your build cycle. And a culture shift. Valuing the maintenance of your application and having camaraderie and collaboration with the security team. I would love to have that. So often I hear stories where, developers on one end and then the security teams on the other end, and they slap them with a ton of CVEs they need to address. But wouldn't it be nice if those could, or at least minimize those in the beginning? Developers had tools that were good, that helped them to decide whether a CV is applicable to them, whether or not they... One is really cool. There was an IDE tool that I added. It connected to, I have X-Ray in my Artifactory database. It connected to X-Ray, and right there in my IDE, I use IntelliJ, by the way, add for IntelliJ. Right there, I could change the POM file and add, upgrade a version in my POM file, or add a new package, because I want to use its cool stuff. And it would tell me right then and there if there were known vulnerabilities in those packages. And not only that, I didn't just get a CVE. I got what I could do to fix it. If there's an upgrade available, if there's any fix available, and then what exactly it did. So there could be an instance where I bring in a library, but I'm not even using the method that's vulnerable, right? I'm using something completely different out of that library. So that's more contextual sensitive and good for developers. We need that psychological safety, no pointing fingers or blaming others. If there's a vulnerability found in production, you work as a team to figure it out, to mitigate it. There's no telling when that vulnerability was introduced. It might have been introduced before anyone even knew about it. All right, implementing security tools. It's not just a checkbox to be checked. Trust but verify. So we have a lot of tools in our face now. This is very much top of mind for a lot of development teams. You're going to be harassed to use all of these tools. Yes, you should use the tools, but make sure that you evaluate them appropriately. And I'm going to talk about just all of the scanners that are out there right now. For me, I really have a problem just taking something and just being told it works. I want to dig in and find out what it's actually doing. So some of the things to look for is the tool just giving you a list of CVEs with no context or any mitigation information. That's not very helpful for a developer who is not a security expert. So that is an immediate no for me. Is it complete? Is it including transitive dependencies? Is it including wrapped dependencies? I had a project, they approached me with a project once where they were using a library that actually had another library included in a directory in that project. So it was wrapped. It wasn't listed as a dependency, is what I'm saying. It was just there. So maybe something more that is a binary search or something to find stuff like that would be better. There's database differences for these tools. So you'll get open source tools. My first question is build something that is that has known vulnerabilities in it, and compare the tools, because every tool may have a different database that it's pulling from. I know some of the paid tools have another internal database that they're pulling from, or a bigger database that they're pulling from. For now, not everything is public information, so you may get some advantages by paying for that information. I kind of hope that that goes away, because I think all of us need to know this stuff. In any case, deal with it as it is. Is the tool itself disruptive, or does it force a developer outside of their normal development environment? I don't want to take something and I have to install another tool, run it through there, but then I have to rebuild, and then I don't remember what version I checked. And I want something that seamlessly integrates with what I'm already doing with my process already, like the tool I just described, where I could have it running in the background and I add a library and it tells me there's a problem. That's really convenient for a developer. And does it prioritize applicable vulnerabilities? We're going to get better and better at this. A lot of tools don't do this. They'll say, these libraries have these known vulnerabilities. Well, it would be nice to know if you're actually using them in your code, right? Have that composition analysis to see if you're actually even using it. This is a good site to take a look at. I told you before, many years ago, there was a paid service that my team and I were all required to take for security training at our job. It was great, but there's a lot of free information too. And check this one out. OWASP has an entire list of things where you can really educate yourself on better, code quality, avoiding a lot of these common weaknesses. It has everything I learned in that paid resource and more here. In fact, all of the Docker suggestions that I gave you earlier, check out the Docker one here. There's a lot more detail, a lot more in-depth stuff to look at. All right, last thing to discuss, who all is invested in trying to solve this issue or at least improve the complex problem of security? And there's a number of organizations. I just listed a few of my favorite here. So I have the CD Foundation, of course. They are, how many of you have heard of the CD Foundation or the CDF? Yay, two people. Okay, I'm going to tell you about it. So how many of you have heard of the CNCF? Okay, a few more. How many of you have heard of Kubernetes? Okay, that's better. All right, so I always equate Kubernetes with CNCF. The organization was formed at the same time that Kubernetes came out, and that was the initial offering of that organization, was that project. It has grown immensely since then. If you have a chance, go to CNCF, check out their website. They have a landscape. It's huge, absolutely huge. Lots of projects in there. The CDF is a sister organization. Both of these are underneath the Linux organization. And the CD Foundation only includes projects that have a strong focus on CI/CD. That is what our organization wants to pay attention to. And we have a lot of discussion right now about the supply chain, protecting that, things like that. The OpenSSF, of course, you might have heard about this organization. They're also working with existing communities to advance open source security. CVE, of course, also working hard to keep that catalog up. And then we have the OWASP, a couple articles I've showed you from them. They are also a nonprofit foundation. They work to improve security as well. Have any of you heard of SALSA? Has that been discussed in your teams at all? So this is an attempt to kind of describe what a healthy system would look like and kind of give a team an idea of how to measure their system's health or what stage they are in maturity. And it's a good start. I think there's a lot more we can do here, but this particular graph here, all of those red triangles describe areas where you could potentially have a problem, something sneaking into your system that you don't want. Again, organizations have their internal research teams that are providing education that is free. This website, research.jfrog.com, lists a ton of information. Latest malicious packages is just one of them. They also have an article on there about the Spring Webflux vulnerability. That is the second QR code that you see. That one's an interesting read. Spring came out with a fix in July 18th, just recently, and our team went in and dug in just to get the details and how it worked and describe, how the vulnerability actually takes place. They have a proof of concept there to take a look at. I love those. Unfortunately, in my company, they're the only ones allowed to do that. I'm not allowed to hack on things. But legally, yeah. Yes, it can be a problem. I heard a story once where someone legitimately found a problem, sent it off to the company, and the company turned around and sued them for hacking them. So kind of touchy. Be careful if you're experimenting with stuff like that. Make sure you have advance permission to do that. All right, so who should be invested? Everyone. Developers, of course. We discussed a lot of reasons why developers. should be invested. Operations, of course. There's lots of orgs that still operate in a bit of silos between operations and developers, but they need to start communicating with each other. DevOps teams, of course. Platform teams, these are the ones that could potentially provide developers with the tools that are safe, so we can spend our time coding our features rather than worrying about our base image being safe, right? Security teams, they have their place. We can do all this stuff in the beginning, but we need our security teams to keep monitoring, keep looking at this stuff, finding new vulnerabilities that we didn't even know about when we coded them up, and keeping track of that. Management, we need training. We need more training for developers. We need to, we have some free stuff, but some of these free resources that I shared with you today, I didn't even really know about until recently. It just wasn't put in front of me before. So we need support from our managers to get that time and money sometimes to do that. And of course, the C-suites. Anytime you try to implement a new process or fix your process, or change an old process, you need to get buy-in from the top. If you don't have that, it's just going to be a struggle the whole way. So make sure that you're not the lone developer on your team that cares. If you are, let's talk later. All right, thank you. I hope this inspires you, gets you to thinking a little more deeply about the problem. I did not kill Larry on this slide because I still have hope. But
All right, we have a couple minutes for questions. Anybody have questions? There's a hand. All right, well, Tim, I'm going to him first and you, okay? There we go.
All right, I just got back from DEF CON, and I learned 2 things you might want to add to your slides.
Okay, I'm taking notes.
You're going to take notes.
Yes.
Good. I like people who take notes. So the one is there's a group at VMware that's building a tool that scans the logs, the output of CI/CD logs.
Nice.
And it works in 2 modes. First mode is it just identifies things like the curl piped into bash and flags that.
Okay.
And then it also compares the logs from run to run. So if something is anomalous is added in subsequent runs, it flags that as well.
That stuff is amazing because, I mean, that takes an awful lot of work to discover, like, what is anomalous, right? I mean,
yeah,
that's pretty cool that they're working on that.
The other one is called SQL Recon.
Okay.
It's a C# program that probes SQL Server databases for issues, just a live database.
Like with the data itself or like with stored procedures and stuff?
I haven't downloaded it to investigate it yet. And
Okay.
The presentation was pretty short.
Okay, cool.
Yeah.
That sounds interesting.
Yeah.
All right.
What is that IntelliJ plugin?
Oh, so there's several out there. The one I was using was JFrog's plugin for IntelliJ, and it connects to X-Ray specifically.
So we have to use X-Ray and JFrog for that one to work?
Yes. If you have an Artifactory server and it has X-Ray installed, you can put in the IP for that instance and you can use it that way.
And what was that one called?
It's just the JFrog IDE plugin. Uh-huh.
Are you using Community or using Enterprise? The guy who asked the question.
I'm using Enterprise. Yeah.
In Enterprise, there's a hidden feature in IntelliJ that will actually tell you that there are upgrades to the libraries you have referenced in your dependencies. They did a release in their blogs, I think it was last fall. It is like the coolest thing that they don't ever talk about. But it'll tell you, by the way, Spring Boot is now at 3.09.
3.12.
1.2, yes, and by the way, you're on 3.1.
Right. That is a feature I've been asked about so many times. It's like, you have to keep polling. Is there an update? Is there an update? Is there a new release? So that is awesome. I'm glad you shared that.
They put a blog out for it. Again, it was like a thing, I didn't hear anybody talking about it afterward, because it's cool. It tells you what you haven't done. It's not CVEs, but it'll at least tell you you are now X versions behind, you probably should go upgrade.
That's helpful.
All right.
I'm just looking at, this code that I have the enterprise version. Now, analyze code, there is a show vulnerable dependencies.
Yes.
Nice.
I mean,
I know, that's what we've been talking about, yeah.
that's one, but actually it tells you which one is vulnerable, not only that there is a newer version, but which ones you want to replace.
Right. So the applicable ones.
Are there any?
That's awesome.
Wait, we have a question here. Wait, let's go in order. I've got a question here, then I'll bring it to you.
So I'm all for just updating the version when we find like a vulnerable dependency. Did you have any advice on figuring out how viable an exploit is and how to write an exception if it's something that just really can't get patched right now?
Something that you can't take it out. You like legacy stuff, you don't know. What's that? Too many? Yeah. So for a few years, I was on the camp of if it's not broken, don't fix it. I think that is really hard when you're already in that position, when you already have old stuff. Is there any way to break it down into smaller steps? I would do that if you're working in like sprints or something. Something I recommend for teams is for maintenance. If you haven't done it already, at least start now. Assign one person. We would have one person that would like deal with fires or stuff like that. And I think this could apply to maintenance as well. Figuring out how much is it broken if we upgrade this, and getting a plan together. We'd call that person Batman. And you need to get them the cape so that they can wear the cape. Otherwise, they won't want to do that job. That was the biggest motivator, was the cape.
Is there anyone using like Fortify?
Fortify.
Yes, made by Micro Focus. It's static code scanner for vulnerability, and it's integrated with DevOps.
I'm not familiar with it.
How about Cordis?
Cordis?
Yeah, Cordis scan for web application.
No.
Okay, thank you.